So now we're going to do our final video for deleting a node from a binary search tree. In the last video, we wrote the code for these three situations, and we did that with this code. Now we need to write the code for this situation where the item that we're removing has a child node on each side. And in order to do that, we'll say else. And now we'll build out this else statement. So for all of the code that we're going to write in this else statement, current node will be this 21 node. So the first thing we need to do is look at that subtree on the right of that 21 node and get the lowest value. And this is where we use that helper method that we created in the last video. So we'll have a variable that we call subtree min, and we'll set it to be equal to min value of current node.write. And current node.write is that 25 node. So the minimum value in that subtree will be 24. Now the next step is to take that 21 node and change its value to 24. So we'll say current node.value equals subtree min, and that will change that value to 24. And now we just have one more step. We need to take that 24 at the bottom and delete it. And in order to do that, we need to traverse through this subtree. And in order to do this, we need to traverse to the right. And this is identical to the line of code that we've already written previously for when we traverse to the right. So the only difference here is this value that we're passing it. We're passing it subtree min. And this will kick off the process of traversing through this subtree and deleting this node. And this is everything that we need in this else statement. So I'll put this in with the rest of our code in a moment, but first I want to bring back this node and point something out. This node will always be open on the left. It will either be a leaf node or it will be a node that's open on the left and has a node on the right. And the reason for that is, if you recall from the previous video, to find the minimum value, it always has to be open on the left. So now let's bring this code back, and I'll move it down here to the bottom so we can bring in the rest of our code. So this is a lot of code here, but let's just break this down. These lines here will traverse left and right, and you will traverse left and right until one of two things happens. Either you find out that the value you're trying to delete is not in the tree, in which case you run this code here, or you actually find the value and you run this else statement. And if you find the value, there are four possibilities. Either it is a leaf node, or that node doesn't have a node on the left, but it has one on the right, or it has one on the right, but not one on the left, or it has one on the left and the right. So those are all of our possibilities. I also want to point out one more thing. This last line that we wrote in the else statement in this video is almost identical to this line here for traversing to the right. So now let's flip over to VS Code and take a look at this. So first, this is that min value helper method that we created in the last video. And I'm going to scroll up. And this is that double underscore delete node method. And we kick off all of our code by running this method down here without the double underscore. And I'm going to scroll up again. And with these lines of code, we'll create this tree. And then we'll print out root and root left and root right with these lines of code. So it should print out 2, 1, 3. Then we're going to delete the 2 node, and that should create this tree. And we'll print that out, and it should print out 3, 1, and none. So I'll run this, and you can see that to start out with, the tree has 2, 1, and 3, and then after we delete the 2 node, that it is 3, 1, and none. And that is our method for delete node.